All right, guys, Mr. Antonucci here, and in this video, we're going to talk about how to get the volume of a solid of revolution when you're revolving about a line that's not the X or Y axis. It's going to be parallel to one of them. So this creates some very interesting situations. Let's look at example 7 here. We have the graph of square root, the line X equals 4, and we're actually going to revolve around that line. So notice the axis of rotation is vertical. So our strip is going to be perpendicular to that. Okay, and notice the region goes from the graph to the line x equals 4, and if I rotate it around, I get a washer. Or no, I don't get a washer. I don't get a washer. I get a disk. Now, the radius of this disk is given by, in this case, we have to think of the right boundary minus the left boundary. And typically that's going to be what you're going to do whenever you have a vertical axis of rotation. If it was a horizontal axis of rotation, you would just do top minus bottom. But because this radius right here is bounded by the line x equals 4 and the square root, notice as you kind of slide up this region, the radius starts at 4 and gets smaller by whatever the square root of x is. So 4 minus y. Okay? So that helps us, y squared actually. Because if you have y equals square root x, then x equals y squared. So you have 4 minus whatever the x value is that you're moving over, but in terms of y, it's going to be x is y squared. So the big R is 4 minus y squared. Another way to think of this is, like I said earlier, right minus left. The right boundary is 4, the left boundary is y squared. Now be careful because this is just the disk method. So the volume is going to be pi times the integral from 0 to 2, okay, because it starts at 0 and the square root of 4 is 2. So that gives us our upper boundary, and it's going to be 4 minus y squared dy. Be careful. It's 4 minus y squared, not 4 squared minus y squared. We're not doing a washer here. We're just doing a disk, but the radius of the disk is bounded by two different equations. Okay, so what we would do here now is FOIL that out. And you have pi times the integral from 0 to 2 of 16 minus 8y plus y squared dy. And this would give us a final answer of 256 pi over 16, which is approximately 17.067 pi. Okay. Next one, we're going to look at this region. It's actually going to be revolved about the line y equals -5 all the way down here. So if you look at the region, it's bounded by 2x and x squared. So it's this region right here. This little looks little because you had to zoom out to get the whole thing. Okay, but we're revolving about a horizontal axis. That means our strip is going to be perpendicular to it, and it's just going to go right here. So this whole thing gets rotated around. Now in this case, we have a washer, okay? But it's not rotated about the x-axis, it's rotated about the line y equals -5. So the big R is going to be formed using the line y equals 2x, and it's not revolved about the x-axis, it's actually about y equals -5, which is actually adding 5 units onto the radius. And here's how that kind of makes sense. If you do top minus bottom for the radius of the outer boundary, you would get minus -5, which actually is 2x plus 5. The inner radius is formed by top minus bottom would be x squared minus -5, which is going to be x squared plus 5. So the volume is equal to pi times the integral of big R squared, so 2x plus 5 squared, minus x squared plus 5 quantity squared dx. Now we need to get the limits. The limits would just be 2x equals x squared, which is going to give you x equals 0 and x equals 2. Okay, so from 0 to 2. All right, so you could FOIL those both out, and be careful when you FOIL the x squared plus 5. You're going to subtract all of that. At the end of the day, when all the smoke clears, you would have 88/5 pi for our answer for this one. Okay, I got one more for you. It's going to be that same region, but this time we're revolving about the line x equals 2, which is a vertical axis of revolution. So our slice is going to be horizontal, which means our thickness would be delta y or dy. So we need to have everything in terms of y. So if y equals 2x, then x equals y over 2. If y equals x squared, then x equals square root of y. To get the limits, since they were not given, you could set up the equation square root y equals y over 2, and then you would have y equals 0 and 4. That's going to give us the limits. Okay, now when we revolve this around this axis right here, we're still going to do right minus left, but we have to be careful here because the axis of rotation is to the right of the region as opposed to the left side of the region. But if you think, let's go from the axis of rotation to the outer boundary, okay, right minus left would be 2 minus y over 2. All right, little r is going to be what forms the inner circle. And if we go right minus left there, we would go from here to here, and that's going to be little r, which is going to be 2 minus square root y. All right, so our volume is pi times the integral from 0 to 4, because remember we're in terms of y, big R squared, 2 minus y over 2 squared, minus little r squared, 2 minus square root y squared dy. Again, if we FOIL both of those out, be careful if you're FOILing the right, the second binomial there, you're going to have to subtract all the terms in that binomial. And again, in this case, we would get 8 pi over 3. Okie doke. All right, guys, that's it for this whole entire section and this series of 5 videos. Hope that was helpful to you. Reach out if you have any questions, and take care.